Okay, let's run all the cells. Okay, so we have already executed this cell. This is for importing the libraries. Let's show the TOC. Run. Next cell to load data. Show the data. Now create two separate entities x and y. Okay, from this data set. Print x. Print out y. And y is 1D array, right? So we need 2D array. Okay, we discussed this in last session in detail. Okay, for feature scaling, we need 2D array. So to convert this 1D array into 2D array, okay, to transform this into 2D array, okay, use this statement. So it will convert this 1D array into this 2D array. Okay, and print out y now again. Now it is 2D array. Now to scale these values, okay, x and y, implement feature scaling. So run this cell. Now check x and y again. Now x has scaled values and y is, so it also have scaled values. So after scaling, because now for this model building, okay, we will be needing this y to be 1D array, right? So we can reshape it again. Okay, so if you check y, it is 2D, but for model building, okay, we need 1D array. So what we can do is we can reshape it again, okay, to transform it again to 1D array, and we can check it again, and now it is 1D array again. Then build the model, build SVR model, support vector regression model. Okay, and here we are using this RBF kernel. Now predicting new result with SVR. Okay, so this step. So this is the statement actually we can use, okay, for predicting a new result. Okay, so here if you want to predict value for 6.5, if you want to predict salary for 6.5 years of experience, then this is normal value, right? So this value needs to be scaled because we actually trained our model on scaled values. Okay, these are scaled values, and here we trained model on scaled values, right? So here you can use scalar x dot inverse transform to get the value back from the scaled values and transform to transform a value, right? So here we want to transfer 6.5, okay, to scale, to a scale, right? So run this. So it will convert it will transform 6.5 into this. This is scaled value, and here we can use scalar x dot transform 6.5 this within regressor dot predict. Okay, so here we are inputting what? We are inputting this value, okay, to regressor dot predict. Run this cell and print out pred result. Now predicted result is this is predicted y, predicted salary, okay, for a candidate who has experience of 6.5 years. So this is predicted salary, but this is scaled salary, scaled value. Okay, so this value, to get the original value or the value on original scale, okay, you can use inverse transform. So you can use scalar y dot inverse transform. Why scalar y? Because this is y. Okay, this is salary, and salary is dependent vector, right? The outcome, the output variable. So scalar y, we trained scalar y on y, right? So call inverse transform, pass pred result, this value, okay, to get value on the original scale. So run this cell, and where's the issue? We have this value. Okay, so this needs to be transformed into that 2D array. Okay, here we are using, because for scaling we always need 2D array. So you can check the error. Error says expected 2D array and got 1D array instead, right? So this result, which is 1D array, okay, needs to be transformed into 2D array. So you can run this cell to transform it into 2D array, and then run this cell to inverse transform, okay, to transform this, okay, in the original scale. Run this and then print pred result, and the pred result is 1,70,370. Okay, so this is predicted salary. Okay, so this model says that if you have a candidate, if you have a person with 6.5 years of experience, then the salary, okay, should be 1,70,370. Okay, this is predicted salary, right? And here actually we are doing this in multiple steps. You can do it in single step also, right? So if you want to do it in single line, add a new cell, use regressor dot predict this statement here. Okay, regressor dot predict, and scalar x dot transform. Okay, we want to predict salary for a person having 6.5 years year of experience, and we are passing this value in 2D array. Okay, if you see it here, okay, it is enclosed in double square brackets. And then after predicting the result, because this result would be what? Run this cell and see, this is the predicted result. This is this predicted result. This result, predicted result, right? This is the same predicted result. And now in separate line, okay, we transformed this result, this 1D array into 2D array, right? Here. So what we can do is here, you can reshape it to dot reshape in the same line. Here we are saying that one row, one column. If you don't want to specify row, okay, in that case you can write -1 and 1. It means as many rows, as many elements are there in 1D array, and one column, right? So here we are not specifying number of rows. Here we specified number of rows, right? Because we knew that okay, there was only one element, correct? So here if you don't want to specify the number of rows, you can write -1. Okay, we don't know the number of rows, number of elements in this 1D array. And then after reshaping it, right, it will, so if you run this, it will, this reshape, okay, will transform this 1D array into 2D array. Run this cell, and now it is 2D array. Now see, this result is enclosed in 2 square brackets. Now it is 2D array. Here it was 1D array. See here, right? Now it is 2D array. And after this, okay, you can use scalar y. You can use scalar y dot inverse transform, okay, to transform this scaled y, okay, into the original value. So here scalar y dot inverse transform and assign result to print new result. Run this cell, and now, so here we are actually predicting, and scaling the salary back onto this original scale, okay, in single line. So if you add one more cell and print new result, print new result, and see it is 1,70,370, the same result that we got here, right? So instead of writing multiple statements, instead of doing this in multiple statements, okay, you can do it in single statement, right? So you are performing here multiple operations, okay, in single line. Now, next step is visualizing the SVR results, okay, and low resolution. So low resolution means what? Low resolution means we have only 10 data points, okay, in our data. So in our data, we have only 10 data points. So if you plot a chart with only 10 data points, okay, the chart will be what? Low resolution. And for plotting a chart and high resolution means, okay, we need more number of points, data points, right? So we will discuss how to create, okay, more number of data points to create chart in high resolution. So let's first implement visualizing the SVR results, low resolution, create a new cell. Okay, so here y is, let's check the y because we will be needing two things. Okay, we will be needing x and y both. So check the y first. Print y. And y is 1D array. Right, it is 1D array. So let's reshape it to 2D array. Right, because we will be needing to transform it onto the same scale, the original scale. Currently, these are scaled values. If you see, these are scaled values. Okay, this is 0. minus 0.72, 2.64. These are scaled values, scale data. Right. So we will be needing what? We will be needing original values, and to get original values back from these scaled values, okay, we need to use what? Inverse transform. And inverse transform, okay, accepts what? That expects 2D array. So currently it is 1D array. Okay, let's add one more cell and try it. Okay, before I'll show you if we don't transform it, then what will happen. Okay, if you want to plot a scatter plot, right? To plot a scatter, plt dot scatter. First parameter is the x. Okay, first parameter is x. Second parameter is y. And then you can specify color. Okay, to specify the color, you want these data points to be drawn in, right? So we want to plot, draw these points in red color. And label, optionally you can set label to data points. And then you can set plt dot title. Okay, you can set title to what? Because this is support vector regression, set it to SVR. Plt dot x label. Okay, we want to show position level on x label. Okay, on x-axis. So position label. Okay, position level. And on y-axis, set y label and show what? Salary. Plt dot grid to show grid. Okay, and plt dot legend to show labels, and plt dot show to show the figure, to show this plot. Okay, If you run this cell, okay, invalid syntax, plt.title. Run this cell, and now there is error. Okay, issue is got an unexpected argument label. Where's the issue? Label, typo. Run this cell again, and now we have this plot, right? Scatter plot. Okay, so if you see here, the scale is, this is position level, and position level is minus 1.5 to 1.5. Okay, but original scale is, if you see here, original values are 1, and value, this position level, okay, goes up to 10, from 1 to 10. Okay, but here in this plot we are getting minus 1.5 to 1.5. It means these x and y, okay, needs to be scaled, okay, to get the values, okay, on the original scale. Okay, so these values need to be transformed. So here for transforming x, okay, we can use, we created two scalars, okay, one scalar for x and one scalar for y. So here, remember that x and y are scaled values of the inputs and outputs, right? So we can print x also here, print x, and we see, okay, x is also scaled. So this matrix of features, okay, has scaled values. So both x and y have scaled values, right? So both x and y, okay, needs to be transformed. So here to transform x, we can use scalar x dot inverse transform, and here scalar y dot inverse transform and pass y, right? So now scalar x dot inverse transform, we are calling inverse transform on both scalar x and scalar y, okay, to get original values back on the original scale, right? Run this cell. Where is the issue? Yes, issue is now here we are trying to, okay, so here issue is we are trying to actually, this x is already 2D array, right? But y is 1D array. And for transformation, we need 2D array, right? So this y needs to be transformed to 2D array, right? So this is the issue. So here what we can do is, here y equals to, okay, we will change y dot reshape, reshape it to len of y. Len of y means number of rows, okay, should be equal to the number of elements in y, and one column, and then print y. Run this cell, and now if you see, this is 2D array, okay, now y is 2D array, and if you run this cell again, now see, now we have these points, data points on original scale. So this is 2, 4, 6, 8, 10. Okay, this is position level, right? Position level is going from 0 to 10, and salary is going from, this is 0.0 to 1.0. Okay, and this scale is, if you see, this is 10 raised to the power 6, right? Okay, now here if you want to plot regression curve, here. So you can use in the second line plt dot plot. Plt dot plot. First parameter. So first parameter x, okay, pass transformed x. Okay, pass transformed x. And second parameter is y. But here we want to plot that regression curve. Okay, support vector regression curve. So here we can use this statement, right? We want a salary to be predicted, okay, for all the values of x, okay, percent in x. Copy this and here. Now, so this is scalar y dot inverse transform. It will actually transform that predicted scaled salary, okay, to original salary or salary on an original scale, right? Regressor dot predict. Here we want to predict what? We want to predict values, okay, for x. X is already 2D and this is already, these are only already scaled values, right? These values in x are already scaled values. So here using this scalar x dot transform is not required, right? So we can pass x directly and dot reshape -1 1 because this predicted result needs to be transformed to 2D array, right? Next parameter is, okay, we can specify color, okay, as we did here. Okay, we can specify color and label. Color blue and label we can set it to regression curve. Okay, run this cell and if you see here, okay, this blue line is the regression line, right? So this is indeed the curve of the SVR model, and as we can see, the predictions in blue go pretty close to the real outcomes, okay, in red. These red points are real outcomes, right, real values, and this blue is prediction, right? Well, this is actually the regression curve. So except for this last one actually, okay, which would make it an outlier. Next step is visualizing the SVR results in high resolution. Okay, create a new cell here, and now we will be needing more points. Okay, we have only 10 points here. So to draw this visualization in high resolution, okay, we need more points. So we can create more points in this range using numpy arrange. So to create more number points, okay, what we can do is here, let's create one more cell and do it here. X points. Okay, and we can use np dot arrange, and we can specify minimum value, maximum value, and the step, right? So here we want to get the minimum value from the x values, right? So to get the minimum value from x values, let's add one more cell here. So we can use main, and we want to get minimum from x, but this x has, let's run this cell. this x has scaled values, right? But we need original values. So to get original values back from these scaled values, okay, we can use inverse transform. Scalar. So scalar x dot inverse transform, right? And pass x. Run this cell. And if you see, we have position levels in x in original scale, okay, 1 to 10. And then we can use min to get the minimum value. And this is 1D array, right? This is 1D array now. And from this 1D array, okay, we can get the first element. And now we have 1.0. So 1.0 is the minimum value, okay, in x. So we can use this as first parameter here. And next parameter is max, get maximum. Run this cell, maximum is 10. Okay, this is max. And to create values, okay, from 1 to 10, more number of points, okay, we can use step 0.1, right? So run this cell and then print x points. X points. And now see, from 1.0 to 9.9, okay, we have now more number of points, right? Interesting. And for all these points, now we can predict y. Now if you predict y for all these points, okay, then this graph will be high resolution, right? So this is the approach we will be using to visualize the SVR result in high resolution. Okay, so use this here. Okay, so this is first line, right? Which will generate more number of x points, data points, right? And then this is 1D array. If you see, this is 1D array. Okay, for scaling, we need data in 2D array form, right? So to convert this 2D array to 2D array, what we can do is, so here x points dot reshape. X points dot reshape. First parameter is the count of rows, right? So we can use here length of x points. Okay, so in 2D array, the number of rows would be equal to the number of elements, okay, in this 1D array, and column, one column. Run this cell. Now this is 2D array. So we have transformed this 1D array, this is 1D array, okay, to this 2D array. This is 2D array, right? So this is the statement. This is the line we will use, okay, for transforming x points, okay, into 2D array. X points, now assign this result, okay, to x points. And then next step is using that scatter, okay, plt.scatter. So we can copy this line, copy and okay. So here plt.scatter scalar x dot inverse transform x and scalar y dot inverse transform y, color red, and data points. Okay, so points will be the same points. And next line is plot. Let's copy all these statements now and we will make changes, the needed changes, right? Okay, so plt.plot. Here the first parameter, it should be what? It should be, because now this we can pass here x points as it is, because x points are already on the same scale, original scale. Here we actually, here x was scaled values, x has scaled values here. Okay, so we used here inverse transform, okay, to get these values on the original scale, but x points are already on the original scale, right? Next statement is here scalar y dot inverse transform regressor dot predict, and here we want to use x points. X points. These x points are on the original scale. So these x points need to be scaled to, okay, this needs to be scaled, right? So we can use what? Scalar x dot transform, okay, to transform x points. Okay, so to scale x points values, okay, we can use transform and then reshape it to 2D array. That's it. So here this plot will plot what? It will plot x points and then it will predict values in x points. First it will actually scale these values and then it will predict results. Okay, the predicted result would be what? Scaled values, and then we are actually, to get the predicted result on the original scale, we are using inverse transform. Okay, we are using inverse transform here. Run this cell, and if you see here, this is high resolution visualization. If you see here, these are straight lines from here to here. This is straight line. See, straight line, then straight line. Okay, but here in this plot, this is proper curve. Okay, so now this is high resolution plot, right? So this is a beautiful curve and high resolution for the SVR model. So in next session, we will cover next regression model, which will be the decision tree regression model. That's all for the support vector regression. Thank you for joining. See you in the next session.